Hey, Matt Mathersum here with Math Madness. Thank you so much for joining us and being a part of this highly critically acclaimed program. You know how we feel about it. We all appreciate it. Even the critics, from what I hear, they appreciate it too. Seriously, thank you. Well, today we will be dealing with something that you thought we would never get around to, and that's taking the derivative of hyperbolic functions. Yowza, what a great way to spend the afternoon. Okay, well, here we go then. Let's just go ahead and get to it. We've got the hyperbolic function of sine of x with this outside function of natural log. Yeah, you already know where I'm going. Yes, the chain rule is going to have to be implemented, so let's just go ahead and get to it. And the sooner we do it, the quicker it gets over with, right? So we're taking the derivative, so that's going to give us our f prime of x, and that's going to be equal to, well, we know the derivative of natural log is just 1 over, and it's going to be over what's in the parentheses here, hyperbolic function sine of x. I'll just restate that here. Okay. And we will be taking the derivative because we said that this is the chain rule that we'll have to utilize. I'm going to put our prime mark there. So our next layer, I think that's what I was going to say, our next layer, let's just call it layer, will be taking the derivative of that sucker. So let's just do it. Going to restate this over here, just the 1 over the hyperbolic sine of x. Did I say hyperbolic sine of x? Well, if I didn't, I did now. Well, what is the derivative of sine? Forget the hyperness for just a second. And what is the derivative of sine in our normal day-to-day walk with trigonometry? Right, it's just cosine. So this will be hyperbolic cosine of x, which I'll stipulate as such. Well, before we go any further, now what do we have? Well, we've got hyperbolic cosine of x over hyperbolic sine of x, don't we? And yes, I do like saying hyperbolic. Okay, well, let's go ahead and do what we did the last time and just do away with the hyperness on both of these. And we just have a regular cosine over sine. Again, in our regular day-to-day walk with trigonometry, what is that? Yeah, it's cotangent. In this case, obviously, it'll be hyperbolic cotangent of x. And how does that look? Well, it looks something along the lines of this. Actually, let me erase I had the S in here. Well, let me just rewrite the whole darn thing. This is what we got. There we go. I will get it right one way or the other. Hyperbolic function cotime of x. Hyperbolic function cotangent x. There we go. I knew one way or another I'd get it out. Well, this is very obviously a very simple example, and that's why I wanted to start us off like this. So this is for all you aspiring engineers and people who want to work with exponential decay and growth. You have a great time with hyperbolic functions. But that's all the time we have for here on Math Madness. I'm your host, Matt Mathersum. I'm going to see you guys really soon.